أعزائي طلبة وطلبات شهادة الثانوية العامة قسم رياضيات لغات، أهلا بكم. النهاردة إن شاء الله سنتطرق لدرس جديد في الهندسة الفراغية، وهو اسمه إيه؟ اسمه زاوية بين مستويين. Welcome my dear student in our program in math. Dear student, now we are study the new lesson. It's titled Angle Between Two Planes. Dear student, what is the angle between two planes? Look at, we have two planes, plane X, plane Y. We have two norm, N1 vector, norm vector, N2, two vectors, angle between them is theta. Dear student, the measure of angle between two planes is the measure of angle between two normal vectors. Look at, we have two planes. What is the angle between two planes? The measure of angle between two planes equal measure of angle between two normal vectors. N1, N2 are two normal vectors of the two planes. Then the measure of angle between the two planes is given by relation cosine theta is norm N1 dot N2 over norm N1 multiply norm N2. Dear student, remember, if we find angle between two planes, we must find angle between two norm of the two planes by substitution about the rule cosine theta equals norm scalar product of N1 and N2 over N1 norm N1 times norm N2. When we find cosine theta, we find theta as shift cosine, the result to calculate angle between two planes, where angle theta more than or equal 0 and smaller than or equal 90 degrees. Now we are translate to example. Find the measure of angle between the two planes B1 such as 2 negative 1 4 dot r vector equal 5 and B2 such as 3x minus y plus 2z equals 4. Remember, dear student, we have two equations of two planes. The first plane 2 negative 1 4 dot r vector equals 5. The second equation by Cartesian 3x negative y plus 2z equals 4. Remember, dear student, the first equation is called the vector equation, but the second equation is called Cartesian equation. What is the required measure of angle between two planes? What is the rule? Excellent student. Cosine theta equals norm N1 dot N2 over norm N1 times norm N2. Dear student, look at the solution. The norm vector, the first plane is N1 to negative 1 4. The norm vector to the second plane is N2, coefficient of 3 of x, y, z is 3, negative 1, 2. Then we find a measure of angle between N1 and N2. This is angle or measure of angle between two planes. What is the N1 dot N2? Look at cosine theta, this rule equals norm n1 dot n2 over norm n1 times norm n2. Look at, dear student, what is the norm n1 n2? We put 2 negative 1 4 dot 3 negative 1 2 pi multiply 2 times 3 plus negative 1 times negative 1 plus 4 times 4, and after we find the result of the scalar product of n1 and n2. What is the norm of n1? Square root coefficient x power 2 plus y power 2 plus z power 2 of the first norm n1. After that, multiply norm n2 by substitution about 3 power 2 plus negative 1 power 2 plus 2 power 2. Answer is, dear student, 15 over 7 root 6. What is the value of 15 over 7 root 6 cosine theta? Then we find the value of theta by x and 7. Cosine negative 1, the result 15 over 7 root 6. What is the value of theta? Is 28 degrees and 58 minutes. Dear student, this example is very important. Why? Because when we find the measure of angle between two planes, must be find the measure angle between two norms. We have n1 and n2, the first equation, by using vector form of the equation, we find n1. After that, we find norm n2 by using coefficient of x, coefficient of y, coefficient of z. After that, we find n1 dot n2, norm n1 dot n2 over norm n1 dot or multiply norm n2. Find, remember, dear student, there is difference between the norm n1 by using square root x power 2 plus y power 2 plus z power 2. After that, by substitution about cosine x equal or cosine theta equals norm n1, scalar product of n1 n2 over norm n1 multiply norm n2. After that, we find cosine theta, then theta equal shift cosine or cosine negative 1, the answer. Then angle theta between two norms is angle between two planes. Now we are translate to another title, parallel planes and perpendicular planes. Dear student, if n1 and n2 normal vector, two planes, then we deduce that the two planes are parallel when n1 parallel n2. Remember, two planes parallel when n1 parallel n2. Then what is required? When planes are parallel, we must prove n1 parallel n2 by using a1 over a2 must be equal b1 over b2 must be equal c1 over c2. The planes are perpendicular if n1 dot n2 equals 0. Look at, dear student, n1 norm vector of the first plane, n2 norm vector of the second plane. If two planes are perpendicular, we must prove n1 dot n2 equals 0. By substitution, then a1 a2 plus b1 b2 plus c1 c2 equals 0. If the plane 2x minus y plus kz equals 5 is parallel to plane x plus ly plus 4z equals 1. Remember, two planes are parallel. Find the value of K and L. Dear student, the first equation of the first plane, equation to x negative y plus kz equals 5. The second equation of the second plane is x plus ly plus 4z equals 1. What is the required? Find the value of k and l. Remember, dear student, when two planes are parallel, what do you deduce? Excellent student. N1 dot N2 equals 0. By solution, look at, dear student, two planes are parallel, then we deduce that A1 over A2 equals P1 over B2 equals C1 over C2. What is the A1 coefficient of x? And the first is 2. Then we deduce that coefficient of the x of the first over coefficient of the x of the second, or proportion of the coefficient of x, coefficient of y, coefficient of z are be equal. Then 2 over 1 equal negative 1 over L equal k over 4. By using cross multiplication to find the value of k and L, then L equals negative 1 over 2 and k equals 8. Dear student, now we are translate to another title is called equation of a plane in space. Dear student, the vector form of equation of a plane in space, look at the point A, its coefficient x1, y1, z1 belongs to the plane, and its position vector a vector and norm direction vector to the plane is n vector a b c and b x y z. Any point on the plane, its position vector is r. Then we deduce that n dot ab vector equals 0, n dot b minus a vector equals 0. Remember, b vector equal position vector r. Then we deduce that n dot r vector equal n vector dot a vector. This equation or form, vector form of equation of the plane. To find the vector equation of the plane, we must know point on the plane and perpendicular vector to the plane. Example. Find the vector form of equation of the plane that has normal vector n vector I plus j plus k and contains point 0, 1, 1. Solution. The vector equation, its form, excellent student, n vector dot r vector equals n vector dot a vector. Then a vector is, or the point A, 0, 1, 1, this point belongs to the plane. By substitution, then we deduce that 1, 1, 1, I, j, k is norm vector n dot r vector equals n vector 1, 1, 1 dot the point 0, 1, 1. After that, we deduce that 1, 1, 1 dot r vector equals 2. By substitution, standard form, we translate to standard form and general form of the equation of the plane in space. What is the standard form and general form of equation of the plane in space? N vector dot r minus a vector equals 0, where n equals a, b, c, the norm vector, but r equals x, y, z, the point A, x1, y1, z1. By substitution, then a, b, c dot x minus x1, y minus y1, z minus z1 equals 0. Then a multiply bracket contains x minus x1 plus b multiply bracket contains y minus y1 plus c multiply bracket z minus z1 equals 0. It's called standard form for equation of the plane. Remember, dear student, we have in vector a, b, c and vector r, x, y, z, point A, vector x1, y1, z1. What is the standard form of the equation of the plane? Is A multiply bracket contains x minus x1 plus B multiply bracket contains y minus y1 plus C multiply bracket contains z minus z1. Remember, dear student, this when required, the required is form standard form of equation of the plane. We deduce this equation. By expand, we find the equation as the form ax plus by plus cz plus bracket contains negative ax1 minus by1 minus cz1 equals 0, consuming as ax1 negative by1 negative cz1 equals d. Then we deduce ax plus by plus cz plus d equals 0 is called general form of equation of the plane. Remember, dear student, the general form of equation of plane ax plus by plus cz plus d equals what? Equals 0. Now we are translate to example to clear that or to use the general form of the plane. Find the standard form and general form of the equation of the plane passing through point 3, negative 5, 2 and the vector n 2, 1, 1 is normal to the plane. Remember, dear student, what is the required? Standard form of equation and general equation of the plane. What is the given? We have point 3, negative 5, 2 and normal vector n 2, 1, 1. Solution. The standard form, its equation a multiply x minus x1 plus b multiply y minus y1 plus c multiply bracket contains z minus z1 equals 0. By substitution, then we deduce that 2 multiply x minus 3 plus y plus 5 inside bracket plus z minus 2 equals 0. Then this is called standard form. By substitution about a, b, c. A equals what? 2, b equals 1, c equals 1. A, b, c is n. x1, x2, x3, x1, y1, z1, x1 is 3, y1 negative 5, z1 is 2. By substitution about standard form, the equation becomes 2 multiply bracket contains x minus 3 plus y minus 5 plus z minus 2 equals 0. We expand and collect like terms. We find the general equation of the plane is 2x plus y plus z minus 3 equals 0. This general form of the plane. Dear student, I am very happy to spend such time with you. Remember, math simple, think, work, produce. Goodbye.